In the previous lesson, I listed out the 4 ways that we can solve quadratic equations. We've done 2 of them already. We can solve them by graphing, and we can solve them by factoring. Now we come to the third method, because sometimes quadratic equations cannot be factored. So how do we find its solutions when it can't be factored? Well, there's 2 ways to do it. This lesson will do the one called completing the square, and there's also one called the quadratic formula, which we'll do in the next lesson. So here are the steps to completing the square. Rewrite the equation to be in the form ax squared plus bx equals c. Now, if you remember with factoring, we always made it so this was set equal to 0. Now, it's possible c is 0, but the point is, when we're doing completing the square, we want all the terms with x on the left, anything without an x, any constants on the right. So everything with an x should be on the left, everything without an x should be on the right. Once you put in that order, your next step is to find half of b. So divide b by 2. Then square the result of step 2. Then add the result of step 3 to both sides of the equation. So make sure you have those blanks filled in, and particularly when we're doing the example on this side of the page, we're going to follow and walk through and make sure we understand what this actually looks like when we're doing the equations, or doing the solving. Okay, so the first question isn't doing the whole process. It just says find the value of c that makes x squared plus 4x plus c a perfect square. So to do that, we just start with step 2, because we're not solving, so we don't need to we don't have an equation at this point. So we just do step 2 and step 3. So our a here is 1, the understood 1 in front of x squared. Our b is 4, and then we don't know c, we're trying to find that out. So half of b is 2, and 2 squared is 4. So that means if c equals 4, this will be a perfect square. And I want to show you what I mean by that, because this might help you understand why the process is called completing the square. So if I plug in 4 for c, I get x squared plus 4x plus 4. And this can be factored. So I need to think what will multiply to be 4 that will add up to 4. Well, that would be 2 and 2. So we get x plus 2 times x plus 2. And it's plenty correct to write it this way, but since these are identical to each other and we're multiplying them, you could also write it as x plus 2 squared. So that's the square we are completing. We're actually finding a way to make it so that we can factor this part, and its result is the same thing twice, meaning the same thing squared. So we'll see that again as we do the whole process on example 2. So this says solve x squared minus 6x plus 12 equals 19 by completing the square. So step 1 is to rewrite the equation so that we have all the x terms on the left and all the constants on the right. So all the x's are on the left, x squared minus 6x, but we need to move this 12 over so that everything without an x is on the right. Then we do what we did in example 1. We take the b, which in this case is negative 6. We divide that by 2, which is negative 3. Then we square it. Now remember, if you plug this squaring in the calculator, you have to put parentheses around negative numbers. You'll get the wrong answer if you don't. because when you square something, it's going to turn out positive. So when we half the middle and square it, you have to, there's a song I learned from a co-teacher long ago. For completing the square, you half the middle and square it. Half the middle and square it. So by the middle, we mean the B, because if you think of A, B, C, B is the middle. So cut the middle in half and then square it. Then we take that number 9 and we're going to add that to both sides. So x squared minus 6x plus 9. And over on this side, 7 plus 9 is 16. So at this point, we can solve the equation because we can factor this, because we say, okay, what will multiply to be 9 and add up to negative 6? That would be negative 3 and negative 3. And x minus 3 times x minus 3 is x minus 3 squared. Now it's okay if you don't, but if you remember on a previous lesson, we showed solving the quadratic equations could be this method right here, where we have something squared equal to a number. And now we take the square root of both sides. The square root and the squared cancel out, leaving x minus 3. The square root of 16 is plus or minus 4. Then we add 3 to both sides. So we get 3 plus or minus 4. So since these are whole numbers, if you wanted to, you could then list what these numbers are, because 3 plus 4 is 7. 3 minus 4 is negative 1. Now, not all of them are going to be all whole numbers, so I'm not going to require you to write it out this way, but I just wanted you to see with this one, this actually does come out to 2 whole numbers. So you could write the answer this way or this way. Now, some of you may look at this and think, wait a minute, I think we could have factored this one. You're right. I'm just showing an easier example to start with, because completing the square does work on the ones that we can factor, but frankly, it takes too long. So its main purpose is for the ones that won't factor. So on a quiz or test, I don't think I'll be giving you one that could be factored and say complete the square. But if I do, that just means it's that much easier. So we completed the square to find the solutions, the places where this function would equal 0. So we'll follow the same steps on the back. So our first step is to get this so all the x's are on the left, all the constants are on the right. So we subtract 3 from both sides. 8 minus 3 is 5. Then we half the middle and square it, giving us 36. So we will add 36 to both sides. The left side become x squared minus 12x plus 36, and then 5 plus 36 is 41. We've now completed the square on this side, meaning we can factor it. We got to think what multiplies to be 36 and adds up to negative 12. That would be minus 6 or negative 6 and negative 6. So this can be jumped to x minus 6 squared, because it's the same thing times the same thing. We take the square root of both sides. The square root and the squared cancel out. We get plus or minus the square root of 41. Then we add 6 to both sides. So we get 6 plus or minus the square root of 41. Now you can plug this in the calculator. They may at times say round to the nearest tenth. So you could type in your calculator 6 plus the square root of 41 and you get about 12.4. 6 minus the square root of 21 and you get negative 0.4. So I would accept that if it asked around to the nearest tenth as well. Now I want to show you just a small shortcut. This isn't huge, but still can save you some time. If you want, you can just skip writing this step because you know you're going to have the same thing squared. Like that's why it's called completing the square, because we're trying to get the same thing times the same thing. So once you're able to figure out what number multiplies to be this, adds to this, you can just jump to this step if you want to. And there's another secret. What this ends up being is always half of b. Half of negative 12 is negative 6. Half of negative 6 is negative 3. So you can actually jump to this pretty quickly by knowing that what's going to be inside the parentheses is half of b. Okay, number 4, we need to start, and this is a negative sign, not a dash. This is negative 2x squared. This is need to be rewritten so that the constant is by itself over on the other side. So I'll add 18 to both sides, giving me negative 2x squared plus 8x equals 18. One thing I need to add to this is with completing the square, you always want it to be just x squared. Like if you look back, well, never mind. So you want it to be just x squared. So if you have a coefficient in front of x squared, you need to divide everything by that number. So I need to divide everything on both sides by negative 2. So here, negative 2 divided by negative 2 cancels out, leaving me x squared. 8 divided by negative 2 gives me negative 4. And 18 divided by negative 2 gives me negative 9. Then I half the middle and square it. So negative 4 over 2 is negative 2. And I square that and get positive 4. So I'll add 4 to both sides. Then I'll factor this. I got to think what multiplies to be positive 4 adds up to negative 4. That would be minus 2, which, how about that? Look what we got right there when we cut b in half, minus 2, or negative 2. So I know it's going to be x minus 2 times x minus 2, which I can rewrite as x minus 2 squared. Then I'll take the square root of both sides. Squared and square root cancel out. But, ooh, wait a minute. We can't take the square root of a negative number. That means there is no real solution for this. There is nowhere this equation would cross the x-axis. There's nowhere that it equals 0. Now just visually so you know why this happens. I don't know exactly what this equation looks like. It's not the point. But there are times a parabola doesn't hit the x-axis at all. So that's why we end up with no real solution on this. Okay. Here we need to follow the same steps. Leave the x's on the left. Move this over so that we have all the constants on one side. That's 24. Like I said, we want this to be just x squared, so we'll divide everything by 3. The 3's cancel, leaving x squared. 9 over 3 is 3. 24 over 3 is 8. So yeah, sometimes we will end up with fractions because half the middle, or half the b, is negative 3 halves. So we're just dividing negative 3 by 2. Then we square that. Negative 3 squared is positive 9. 2 squared is positive 4. So we add 9/4 to both sides. That gives me x squared minus 3x plus 9/4. And you're welcome to plug this in your calculator to help you. 8 plus 9/4 is 10.25. Or you could also write it as 41 over 4 if you prefer, if you want to keep it a fraction. Now you may say, how in the world am I supposed to factor this? Well, that's why I told you that hint about when we factor, It turns out that what's in the parentheses is always half the b. So that negative 3 halves is what's going to go in right here. Now factoring is not always that easy, but with completing the square it is. You're always going to have half the b right here. So then we take the square root of both sides. We get plus or minus the square root of 10.25. Then we add 3 halves to both sides. So one form of the answer would be to say x equals 3 halves plus or minus the square root of 10.25. Or if you type that in your calculator, you would get that x equals 4.7 when you do 3 halves plus that square root, or negative 1.7 when you do 3 halves minus that square root.